Welcome to the Network Engineering Video Blog. I'm your host, Michael Crane. Well, today we're going to look at some load balancing testing over the lag. The spec for the lag is 802.3 AD. And I'm going to try to keep this video short. I'm talking around 15 minutes. Because I've gotten some feedback that, from people that say, oh, they're too long. So let's get started. Okay, here's our test bed set up, and I know you guys have kind of seen this before. This is the Xena gigabit test set. It's got 3 100 meg links going to the Cisco 3750 switch. Okay, and it's got 3 links that are bundled into a lag. We'll call it lag number 1. It's got 3 links that are bundled into lag 1 here, and they're each 100 meg Ethernet links, and going to the Cisco 3845 router. And then the router's got a gig port going over to the Xena test set. And these two boxes, these two Xena boxes, are actually the same test set. I'm just drawing it this way to make it easier to look at. So what we're testing today out the load balancing is, so anyway, we're going to initiate a 10 meg stream, and it should get to this 3750 switch right here and load balance it across one of these 3 links inside the lag. And what does load balance mean? Load balance is if we start 3 separate streams on different MAC addresses or different ports that have different MAC addresses, it should put those streams on 3 different links inside on this lag right here, and that's load balancing instead of sticking 2 streams on 1. And the same goes true for the other side. If we start 3 different streams going this way, the Cisco router should load balance each stream, 1 stream on each link inside the lag. To kind of balance everything out. And the way it's load balancing in the 3845 is we're using the destination MAC. So it's going to look inside these packets and see where the destination MAC address is, and see that it's going to be either E0, E1, or E2, and so it knows that there are separate MAC addresses, and it should load balance it properly. So, and vice versa, this is looking at the source MAC address, right? So it should see E0, E1, and E2, and it should split it up. Okay, so let's go do some testing. One other thing I wanted to mention was this conversation. And if you look at the spec, they consider a conversation to be, so if you have a PC over here, all right, and it's communicating to another PC over here. Sorry for my drawing. And it's on port E0 and is talking to port E3 over here. That is one conversation. And the reason why is because the switch will not try to split up let's say you have 100 megs or 60 megs coming in. It's not going to try to do 20 on this link and 20 on that link and 20 on that link. That is not load balancing. That is load balancing, but that is not what the switch does. And the reason why they do it is because it's too hard to try to reassemble and keep all the packets in order. because if you start getting them out of order, you're going to have some real problems. So the switch definitely won't split up one conversation. So if this is the 60 meg conversation right here, let's say it's doing a file transfer or something. Like I said, it's not going to split it up into 320s going across the lag. It's going to use one of the links and just stick all 60 meg across that. And that has some limitations that you should be aware of, because so this has got a gig port right here. Let's say, well, it does. And let's say you start a 200 meg conversation going this way. Well, this has no problems with it. The 1 gig port has no problems, but when it hits the router right here, he's going, well, I don't have 200 megs, so he's going to have to try to pick, one of these links and shove that 200 megs on it, and basically what's going to happen is 100 megs of it's just going to fall, be dropped. And so he'll only be able to get 100 megs across one of the links, because like I said, he cannot split them up to load balance it.
Okay, so I've got the gigabit Ethernet test set pulled up. I've got a couple windows here that I'll show you. On the left side here is the Ethernet switch, and the right side is the router. And here's our drawing right here. So in our drawing, you can see the left side is the switch, and the right side is the router. Okay, and in this test set, I'm not going to go through how to set this up. I've done that on previous videos, but I do want to point out that I added these broadcast ARP streams, and I think I named them, broadcast ARP. You can see right here, and what these are doing, if you look at them real quick, is it's just sending a an ARP out asking where is the endpoint. So if we look at the drawing, what he's doing from this side over here, from E0 right here, he's sending an ARP out and asking where 162 lives. And what that's doing is it's MAC address table inside the Ethernet switch and inside the routers here from timing out or aging out. They have like a 5-minute age out time. So what I've done here is I've added ARP streams to each port basically. You don't need to do it for each stream, it's just each port, because you got to keep the MAC address in the address map table. Oh, well, let's go over here to the stream configuration. This will be a little easier to look at. So let me sort this. Okay, so is ports 0, 1, 2, and 3, and these are all the streams on it. You can see the broadcast ARPs are already enabled. I have those already running on each port. I have the others suppressed. Now you can't leave them, if you put them in a disabled state, you won't be able to turn them on unless you stop all the testing on the port. And we don't want that. We want to keep on cruising. So what we're going to do first is I'm going to test from the router side going this way. All right. So I'm going to start a stream and see where the router puts it on the lag. So let's see here. We'll go down to port 3, and we'll just start. This is a 10 meg stream. It's UDP, by the way, and I'm just going to enable them. And we're going to go over here to the global stats, and let me clear them out real quick. And I'm looking in the stream stats. If you look in the port stats, you're going to see stats from all the ARPs. streams, and we don't care about that. And I can show you. Well, I think I showed you in another video how to delete the stream ID out. So I won't go through that again. If you have questions about it, just let me know. Anyway, so you can see we're going from the router to the switch, and just ignore these port numbers. They're just for me to keep track of which one is which. And we're transmitting 10 meg. We're receiving 10 meg. Okay. And let's see where it put it. Okay, so we'll do a show int sum. Okay, so gig 01. You can see it's I'm looking right here, by the way. You can see it's about 10 meg. This is averaged. It's kind of a running average over 30 seconds, so it takes it a while to kind of get to 10 meg, but okay. And it's setting it out. Oh, there it is right up underneath it. Fast Ethernet 01. So let's look at our drawing here real quick. So what we're seeing is coming across gig 1 here into the router, and it's hitting port 10, and coming across like that. Okay, so that's excellent. Now let's go ahead and fire up a second stream. So we'll go over to stream configuration, and we're going to start the second stream here, enable. Okay, let's go look at our stats. We can see our second stream coming in here. I'm going to clear the counters out. You can see we're from the router to the switch. We're transmitting about 10 meg and receiving about 10 meg. Excellent. So let's go see where it put it. Okay, so here's it's coming across the gig E. It says it's under the receive, so it's receiving from the Xena test set right here on gig E. And it looks like it picked the second link in the lag. And I know it doesn't show 10 meg, but like I said, there's a 30-second running. Yeah, see, it's catching up. Okay. So, that's very good. So, we'll just go ahead and map that out real quick. So, it's coming across here. Actually, it's doing this. Almost exactly. So, it came across here. It's hitting this first link right here because it's sorting on the destination MAC, remember. Coming across here and second port. Perfect. Alright. So, let's start this third guy up. Go over to stream configuration. Enable him. Check the stats. Yep, I can see him pop up in there. Okay, we're transmitting 10 meg. Receiving 10 meg. Very good. Go to the router. Perfect. You can see it's got all three of them on here. And it actually picked the third link in our lag. Exactly the way it was supposed to work. And we can watch this running average for a second. So you can see that now they're all kind of catching up. Saying this should go to 30, and then we should have 10 meg links there. Okay. And let's go to our drawing here. And so we started this third one. Came across here, came down to here, and did that. That is textbook the way it is supposed to work. Okay, so let's try this testing from the switch side. Now it's going to be load balancing based on unique the source MAC address. Okay, so the C0, E1, and E2. So let's pull up our Xena manager. and go over here to stream configuration. I'm just going to go up to port 0 here from switch to router, right? I'm just going to enable this guy. Okay, we're going to go over here to the global stats. Yep, that looks good. We are transmitting about 10 meg, and we are receiving about 10 meg. Perfect. Okay, let's see where the switch put this guy. Show int sum. Okay, so this fast Ethernet 10 is where it's coming from, the Xena test set, and it is put it on 44. Okay, and I know, like I said, this is a running 30-second average on these interface stats. So yeah, you can see it's catching up now. There's port 1. Okay, very good. So let's go ahead and draw this out. So we're coming from here, hitting the Ethernet switch. Now we're going across 44 right here, hanging down to this gig, and going in like that. Okay, perfect. So let's go ahead and start a second. So go over to stream configuration, go over to port 1, enable, and go to our global stats. Okay, you can see we're from going to switch the router, transmitting about 10 meg, receiving 10 meg. Perfect. Let's go over here to the switch and see where we put them. Okay, so here's coming inbound on port 2 right here of the Ethernet switch. Well, looky there. He stuck them on the exact same link. Okay, so let's go ahead and draw that one out. So we came across port 2 right here, and instead of it picking one of these two other empty links on the lag, it decided to stick it on the first one. Like that. So let's go ahead and do the third one real quick. I can tell you that I know this is going to fail as well. Yeah, so instead of load balancing it like the router did, it stuck everything on the first link of the lag. Okay, so you might be asking, okay, so what's the fix? And I can kind of give you one that I ran across that helps, and that is, instead of using just source MAC, which unfortunately is the default in the switch, you can do a config T, go to load, it's a port channel load balance, and we're doing just layer 2, so we can only really do the max, right? And we might be able to do the IPs as well. I really don't know, but I didn't turn on any IP routing inside the switch, so I'm just going to assume that the IP stuff wouldn't work. But anyway, what we can do is, instead of using the source MAC, which is the default right here, we're going to use source and destination MAC. Okay, so I'm going to do config T port channel load balance source destination MAC. Okay, so let's go up here. We'll start our first stream. Oh, enabled. Go check our stats. Oh, there we go. Yep, transmitting 10, receiving 10. Good. I'll do our show and sum. Okay, so it's coming in on port 1 here, and you know, as counters hasn't caught up. Look where it put it. It put it on, what is that, the last link in our lag? Yeah, so put it on the last link in our lag now. Why? Who knows? But anyway, let's do another show int sum here. Yeah, so you can see the counters are catching up now. Yeah, so it's on the last link. That is truly bizarre. Anyway, so, and we don't care. I don't care where it puts it as long as it puts it on different ones, right? So let's go to our Xena manager here and let's fire up the stream configuration. Let's fire up the second stream. Go to global stats. Okay, we're transmitting 10, receiving 10, good. Okay, let's see where it put it this time. Okay, so you can see we're on port 2 now. Okay, where did it put it? Ah, I guess it's counting backwards. So it stuck it on 45, which is good. That's good. At least it's not on the same port as the first stream, so that's good. Okay, so let's go fire up the third one. Stream configuration, enable. Let's go check our stats. Transmitting 10, receiving 10. Okay, let's see where our Mr. Switch put it. Okay, so here's our port coming inbound. Oh, well, instead of putting it on 44, which would have been ideal, he stuck it on port 45 again. So just to recap using our drawing, sorry I forgot to do it on the drawing here. So we started the first one up, right? And it put it on the very last port in our lag, port 46, came across here like that, and up like this, like that, right? And we started the second one. He actually put it across the middle one, and you know, kind of like that, right? And we started this third one, and instead of using this last port right here, oops, instead of using port 44 right here, it put it on 45. Something like that. You get the idea. So, and I actually knew that was going to fail because there is a problem with what they call the hashing in this 3750.
So this is obviously a problem. As you can see, with the default source MAC doesn't seem to work at all, and the source destination MAC works better. So I would suggest using that, and I believe that if we would have been able to add a fourth stream on here with a completely different MAC address, I believe it would have actually put it up on the first link. But I didn't want to go through the hassle of trying to set that up and test it. I also believe that if we would have added a fourth link into our lag, that it would have load balanced better as well. And that's kind of some workarounds that's online. And I'm telling you, this bug has been around forever. You know, it was around in the 6400 series Ethernet switches. And I wanted to introduce you to this bug that's been around forever. Has, you know, got some weird workarounds and notes like that. This is, ladies and gentlemen, your introduction to the Cisco WAD. All right, and the symbol for the Cisco WAD are 3 ovals stacked on top of each other. Sometimes a little curly-Q coming up out of the top of it. And what WAD stands for is works as designed. And so Cisco either won't fix it, they don't want to, or they can't fix it. And so they give you these little goofy workarounds to try to work, you know, to make it work. And one of the engineering notes you'll see is to only build lags with even number of links. They either have 2 links, 4 links, 6 links, that sort of thing, right? And then it'll load balance properly. So anyway, I just wanted to introduce you to this term, and I also wanted to bring up the reason why it is so important to test. You know, Cisco makes excellent products. Don't get me wrong, I love them, and they're not the only people that have WADs, believe me. They just happen to make it famous, at least in our engineering circles, but it is so important to test your network, because you know, you go out, you buy this top of the line equipment, and you find these little things, and if you don't test it, this is going to really, you know, give you some heartburn when you go to turn this network up, and you're only getting, you know, a third of your bandwidth, right? One last thing I also wanted to point out before I let you guys go is a 300 meg lag, as you probably can tell, is not the equivalent as having a 300 meg pipe. And I just wanted to, these are not equal. For one thing, the biggest conversation you can have on a 300 meg lag with 3 100 meg links in it is 100 megs. Right? You can have a 300 meg conversation on a 300 meg pipe. You do get, you know, some redundancy built into this lag, but unless you're looking for that redundancy, I would always go with a larger pipe. Anyway, I hope you liked this video. If you have any questions or comments, leave them in the comments below the video, and I'll try to answer them, and I'll see you next time.